Section 2.7, Transformations of Functions. We're going to look at transformations of functions, meaning we're going to look at taking a function that we know and shifting it up, down, left, right, and then also reflecting it across the x-axis and the y-axis. So those are the transformations we're going to focus on. So let's look at the notation. First, it says to change the parent function. So our parent function we're going to label as just simply f of x, okay? Now, I have an example over here that we're going to follow or use throughout, which is y equals x squared. That's the specific function we're going to use in our example. Now, y equals f of x plus c. So I'm adding a constant. That plus c means I'm adding a constant outside of the function. Okay, our example is y equals x squared plus 2. So x squared is my parent function, and I'm adding 2 on the outside. When you add on the outside, you are shifting your graph up. So this example in particular, y equals x squared plus 2, is a shift vertically up 2. Now, similarly, when you have f of x minus c, so when you're subtracting on the outside, that's going to be a vertical shift down. Okay, so in our example, we have y equals x squared minus 3, which means we're going to take the function x squared and we're going to shift it down 3 units. So our basic parabola is being shifted down. Now, when you have something added on the inside, that kind of transformation is a horizontal transformation. So we have f of x plus c, so adding on the inside. My example over here is y equals the quantity x plus 4 squared. Well, when you're adding on the inside, that's actually a shift to the left. Okay, so our particular example of x squared is going to be shifted to the left 4 units. And we'll look at what these graphs look like later. All right, our next one, you can probably guess what the next one's going to be. When you're subtracting on the inside, so f of x minus c, that is going to be a shift to the right. All right, in our example, we have y equals the quantity x minus 5 squared. So we are shifting the x squared graph 5 units to the right. So we're going to go right 5. The last 2 transformations we're going to discuss are reflection across the x-axis and the y-axis. So here, if you have a function and you have it a negative on the outside, okay, so our example over here is y equals negative x squared. That negative out in front is going to reflect your graph across the x-axis. So we're going to reflect across the x-axis. Right? So that x squared, which is our typical parabola, just to kind of show you over here, here's my parabola. Well, if I have my x and y axis and I'm reflecting across the x-axis, my new graph is going to look something like that, reflection across the x-axis. So again, you can guess the next one when we have a negative on the inside. So my example over here is y equals the quantity negative x squared. When that negative is on the inside, it's going to be a reflection across the y-axis. See if I can get my pen to work. And it's really hard to see a reflection across the y-axis in this particular example. So let me show you. We know our basic parabola looks like that. Now, a reflection across the y-axis is going to give us the same exact parabola. Okay, so again, it's very hard to see in x squared, but you're going to see later when we're dealing with different parent functions that you will be able to visually see that reflection across the y-axis. Example 1, describe the transformations. We're going to be using the parent function f of x equals the square root of x. Okay, f of x equals the square root of x is our parent function. So if you recall, just so you guys know, a square root function looks like that. Okay, so what we're doing is we're looking at what's going to happen to that square root function when we do these different transformations. Now, you don't have to graph these, okay, but I just wanted to refresh your memory on what the square root function looks like. Now, this first one, g of x is equal to the square root of x minus 5. This minus 5, we are subtracting on the inside. Subtracting on the inside. So if you refer back to the chart that we just filled out, when you subtract on the inside, okay, we know anything that happens on the inside is going to go either left or right. And when it's subtraction, that means we are going to have a horizontal shift to the right. So this is a shift to the right 5. All right, moving right along, h of x is equal to the square root of x plus 3. Notice we are adding on the outside. It is outside of the square root. Okay, when you're adding outside, that is going to send your graph up. So this particular one is going to go up 3 units. And the very last one, notice we have this negative out in front, okay, outside of the function. A negative outside the function is going to be some kind of reflection. And it is actually going to be a reflection across the x-axis. Example 2. This time we're going to describe the transformations of our parent function f of x is equal to the absolute value of x. Again, just a reminder, let's think about what the absolute value of x looks like. We know that the absolute value of x is our function that looks like a v. Okay? So just think about taking that graph and shifting it up, down, left, right, or doing reflections across the x or y axis. This first one, we have absolute value of x plus 7. This plus 7 is happening on the inside of our function. Remember, inside means we're shifting to the left or to the right. A plus is going to be a shift to the left. So we're going to shift this one to the left 7 units. Part B, h of x is equal to the absolute value of x minus 2. We have a subtraction of 2 on the outside, so outside of our absolute value. We know that outside we're going to go up or down. When it's minus, that is going to be a transformation down. So this particular function is going to go down 2. Part C, k of x is equal to the absolute value of negative x plus 5. Notice we have 2 transformations going on. We have this negative and we have this plus 5. This negative is on the inside, okay? A negative on the inside is going to be a y-axis reflection. And then we have another transformation. We have plus 5 outside of the absolute value, and we know outside it's going to go up or down. Since it's positive, we're going to shift this graph up 5. So this had 2 transformations. Example 3, describe the transformations of f of x equals x squared. So this goes back to that example we originally used when we were filling out our chart. Now, the first one, notice we have a minus 4 on the inside, and then we have a minus 1 on the outside. So we're going to have 2 transformations. A minus 4 on the inside is going to be a transformation to the right. So we're going to take our x squared function, which we know is a parabola, and we're going to shift it to the right 4. And this minus 1 on the outside is going to shift it down 1. So 2 transformations. Part B, h of x is equal to x plus 6, the quantity squared, plus 5. Again, we have 2 transformations. We have this plus 6 on the inside, which is going to shift it to the left 6. And then we have a plus 5 on the outside, which is going to shift our graph up 5. And for part C, notice we actually have 3 transformations. We have this negative outside in front of our function. Then we have a minus 1 inside the square. And then we have this minus negative 2. Well, we know that minus negative 2 really means plus 2. So let's rewrite it before we go any further. So I'm going to cross this out. I'm going to write that as plus 2. So we have 3 transformations going on. First one, this negative on the outside is going to be a reflection, and it's going to be a reflection across the x-axis. A minus 1 on the inside is going to be a shift to the right 1. And our last transformation, this plus 2, is outside of the x squared, so that is going to be a transformation up 2. In example 4, we're going to start looking at what the graph actually looks like. So we understand what the different transformations are. Now we're going to graph those transformations. Example 4 tells us to graph the function using shifts and reflections, so using transformations. We're going to take the function x squared, and we're going to have it go up 3. That's what that plus 3 means. So my parent function is y equals x squared. That's my basic function. So down here on my graph, I've gone ahead and I went and plotted what 5 points from the graph of y equals x squared. So just so you know what's going on, I plotted the x values negative 2, negative 1, 0, 1, and 2. When you plug negative 2 into x squared, you get 4. Negative 1 in, you get 1. 0, you get 0. 1, you get 1. And 2, you get 4. So I plotted those 5 points. That is your basic x squared parent function. Now we have to look at what this plus 3 is going to do. Well, we know that this plus 3 is on the outside, so that's going to be a transformation up 3 units. Okay, so since I've already graphed 5 points of my basic x squared function, I can simply take those 5 points and just shift them all up 3. So this first point here is going to go up 3. So I'm going to take, actually, let's take my negative 2, comma 4, and take it up 3 units. All right, this one here, I'm going to take my 2, comma 4, and shift it up 3 units. All right, and then I'm going to erase those just so they're not in my way anymore. Okay, I shifted those 2 points up. Then I'm going to take my points negative 1, 1, and the point 1, 1, I'm going to shift those up 3 units. So this negative 1, 1, if I go up 3, 1, 2, 3, I'm now here. And if I take 1, 1, and I go up 3 units, I'm now here. Okay, and again, I'm going to erase those. I'm going to erase those points I had there previously, so I don't get confused. And my very last one, the point 0, 0, again, I'm going to shift it up 3 units. 1, 2, 3, and erase that point, that original point. Not letting me draw it. Let's see. Okay. So again, I'm going to erase that original. So now I have 5 points on my new graph of x squared plus 3. Go ahead and connect those, and you're going to see you have a parabola, your basic x squared function, just shifted up 3 units. All right. If you want to look at the table of values just for a comparison, and you don't have to do this every time, but my new points, notice my x values didn't change. -2, -1, 0, 1, and 2. Okay, let's plug -2 into our new function. -2 squared is 4, and 4 plus 3 is 7. So notice on my new graph, I have the point -2, 7. When I plug -1 into this function, -1 squared is 1. 1 plus 3 is 4. So I have the point -1, 4 on my function. Okay? When you plug 0 in, you get 3. When you plug 1 in, you get 4. And when you plug 2 in, you get 7. So if you look at the y values of my original function and the y values of my new function, I just simply added 3 to all of the y values, and that shifted my entire graph up 3 units. In example 5, I'm going to graph the function using shifts and reflections again, but this time I'm dealing with an absolute value function. So I've already plotted 5 points that represent a basic absolute value function. So y equals the absolute value of x. So I plotted those points. And over here, I'm going to make the table of those values. So my x's were -2, -1, 0, 1, and 2. Okay? When you plug -2 into the absolute value of x, you get +2. When you plug -1 in, you get 1. 0, you get 0. 1, you get 1. 2, you get 2. So that's where I came up with those 5 points. Now, absolute value of x minus 2. This -2 is on the inside. So an inside we know is going to go left or right. And this is actually going to be a transformation to the right. So this is going to shift it to the right 2. So I'm going to take each of those points and shift them to the right 2. So I'm going to start at 0, 0. I'm going to move it to the right 2 and erase the point I originally started with, just so it's not in the way anymore. So I move that point. Then I'm going to shift my point 1, 1. I'm going to shift that over to the right 2 and erase that. Whoop, not the highlighter. Erase that point. So each point I'm moving to the right 2. Okay, and I'm going to erase those previous points. So now I can see that I've just taken that absolute value function, which looks like a V, and I've shifted it, the whole thing, to the right 2. So my new function, or my new graph, is going to look like that. And again, we can examine what happens to the values. Well, now we have the point, let's just go ahead and label our points right here. We have the point 0, 2. Then we have the point 1, 1. Then we have the point 2, 0. We have the point 3, 1. And we have the point 4, 2. Okay, so that's a table corresponding to the new values. And again, if you're unsure of the transformation, go ahead and just simply plug in values into this function. When you plug 0 into here, 0 minus 2 is -2. The absolute value of -2 gives us 2. So that's where we came up with this point. So you can always just recreate the table to visually see what's happening. Example 6, graph the function using shifts and reflections. This time we have f of x is equal to the opposite of the absolute value of x plus 1 plus 2. So notice we have several transformations going on in this problem. This negative out in front is going to be a reflection. And since it's out in front, it's going to be a reflection across the x-axis. This plus 1 on the inside, we know when it's on the inside, we're going to go left or right. So this plus 1 is actually going to be a shift to the left 1. And then this plus 2 is on the outside, so that's going to shift our graph up 2. Now, just make a note to yourself. You always want to do reflections first. Okay, you have to graph the reflection first, and then you can do your shifts, your horizontal and your vertical shifts, so up, down, left, and right. So let's reflect basic absolute value function across the x-axis. So again, I have 5 points plotted. That's what an absolute value function would look like. Now, if I reflect that across the x-axis, I'm going to now have this set of 5 new points. If I can get them to graph. Let's try this again. All right, no worries. So I'm going to erase what I had previously. All right, so I know right now I have this upside down V. Okay, I've reflected across the x-axis, so I have this upside down V. Now, after I do my reflection, I can do my left 1 and my up 2 at the same time. So I'm going to take each of these new points, and I'm going to take each of them and move them left 1 and up 2. So this first one on the left, so the point -2, -2, I'm going to go to the left 1 and up 2, and I have my new point. The next point, which is -1, -1. Again, I'm going to go to the left 1 and up 2. The point 0, 0, I'm going to go left 1, up 2. The point 1, -1, again, left 1, up 2. And you can see I'm still going to get that V, okay, and it's still going to be upside down. It's just every point is shifted to the left 1 and up 2. And this last point, I'm going to go left 1, up 2, and I'm going to erase my intermediate points, and you can leave them on your graph so you can see, but I'm going to erase them just because I want the graph to be clear for you guys. And when I connect these, I see that I have that V shape still. Okay, so that graph is reflected across the x-axis first, and then from there I take every point and shift it to the left 1 and up 2, and this is the resulting graph. Example 7, write an equation for a function whose graph fits the description. The graph of f of x equals the square root of x is shifted 3 units left, reflected across the x-axis, and shifted down 2 units. So we need to take our parent function, which is the square root of x, and we actually have to do 3 transformations. We need to go ahead and put in there that is shifting 3 units to the left. It's being reflected across the x-axis and shifted down 2 units. So I'm going to start off by saying, okay, if it's shifted to the left, I know that I'm doing something on the inside of the function. Reflected across the x-axis, that's going to make sure that I need to make sure that I have a negative outside of my parent function, so outside of that square root. And the last transformation is shifted down 2 units. Okay, down is also on the outside. So we need to put those 3 pieces together. So my new function, instead of calling it f of x, I'm just going to call it g of x. So my new function, when I piece it together, is going to be negative square root, and we're doing 3 units to the left, and we know if we're doing it to the left, that's going to be a plus on the inside. So it's going to become x plus 3. And then down 2 units means a minus on the outside, so I'm going to have minus 2 hanging out here. And again, always look back at your graph and make sure that you did the right transformations. This negative out in front gives us a reflection across the x-axis. This plus 3 on the inside is going to shift us to the left 3, and this minus 2 on the outside is going to shift us down 2. Example 8. Write an equation for a function whose graph fits the description. This time we have the graph of f of x equals x cubed reflected on the y-axis or across the y-axis and shifted up 1 unit. So again, let's think about our transformations. When we're reflecting on the y-axis or across the y-axis, we know that's going to give us or indicate that we need a negative. That negative needs to be inside our parent function. All right, and shifted up 1 unit, we know is going to be outside. And if we're going up, it's going to be a plus on the outside. So again, we need to piece those two transformations together with our parent function, which is f of x equals x cubed. So I'm going to call this function h of x. And again, it doesn't matter what you call it. I'm just going to use h of x this time. So I need a negative inside my parent function. That means inside this cube, the negative needs to be cubed. So the way I'm going to write that is negative x quantity cubed. Okay, that gives me the negative on the inside that I need. And then since I'm shifting up 1 unit, I need a plus 1 outside of the cube. So my new function that satisfies those conditions are h of x equals negative x cubed plus 1. Example 9. Use the graph of y equals f of x to graph the following function. So this image that we have down here, this graph, is our f of x, or y equals f of x. Okay, so these two segments pieced together represents the function that I'm going to make these transformations with. So when we look at g of x equals negative f of x plus 3, we have to look at the transformations that are going on. This negative is outside of the function. If you have a negative outside the function, that means you're going to have a reflection across the x-axis. All right, and then this plus 3 is located inside the function. So that means I'm going to take this function and I'm going to shift it to the left 3. Okay, now remember, always do reflections first. Okay, always do reflections first. So make sure you make that note. So what I'm going to do is I'm going to reflect this graph across the x-axis. Now notice I've made 3 key points, okay? I have this point negative 5, 10. I have this point 2, 8. And I have this point 7, 1. I'm going to use those 3 points to help me with these transformations. So I'm going to reflect those points across the x-axis. Okay? So I went ahead and I made the graph for us. So let's look at what that looks like. All right, this is what it's going to look like. Again, just to show you the points. This point right here was negative 5, 10. This point was 2, 8. And this point here was 7, 1. When I reflect them across the x-axis, I'm now going to have the points negative 5, negative 10. I'm going to have the point 2, negative 8. And I'm going to have the point 7, negative 1. Okay? Once I've done that x-axis reflection, I can move on to the second piece. Okay, so referring back to our original problem, remember the second piece says to take that new image and move it to the left 3. So when I take all of these points, okay, I'm going to take this point, and this point, and I'm going to shift them all to the left 3. Head and shifted those points, so let me slide down. I've taken those 3 points, which is this red graph, okay, and I shifted each of those points to the left 3 units. Okay, so my final points are going to be the ordered pair 4, negative 1. All right, down here we have the ordered pair -1, -8. And the last point of my new green graph is the ordered pair -8, -10. So again, the blue was my original function. I took that original function and first reflected across the x-axis, which gave me this red graph. And then the last transformation was to take that red graph and shift each of those points 3 units to the left. So my green graph is my solution. Example 10. Use the graph of y = f of x to graph the following function. So this is the same exact graph that we had in the previous problem. So that is my y = f of x. My function is this blue graph. Okay? And what I'm going to do is I'm going to do some transformations. So let's look over here at y = f of x minus 3 minus 2. This minus 3 is on the inside. We know if it's a minus on the inside that that's going to be a transformation to the right. So this graph needs to be transformed to the right 3. And then this minus 2, since it's on the outside, is telling us that we need to shift our graph down 2. Okay, so we need to go to the right 3 and down 2 units. So again, I went ahead and graphed it for us, okay? We can just take those 3 key points. Remember, the 3 key points are this one, and this one. And we can do both transformations at the same time. We can take each of those points and simply move them down 2 and to the right 3. All right, so down here, I took each point, I moved it down 2 and to the right 3, down 2 to the right 3, and your final points of your new graph should be the ordered pair -2, 8. Okay, that's this one right here. Then we should have the ordered pair 5, 6, which is that one right there, and the last one should be 10, -1. That is the graph translated 3 units to the right and 2 units down.